Hey guys, it's Chili here. Welcome back to Advanced C++ Tutorial 1. Today we are going to be learning about linear equations and graphing straight lines. Now, I did this tutorial in the old series in beginner episode 10, and I got complaints from two types of people. First, people were like, Chili, we learned this stuff in junior high or in high school. Why are you teaching this? And I understand that, but it's a super important topic and not all people know this. And to evidence that, there were another group of people who are like, oh my god, the math, it burns. And while that may be the case, this linear equation stuff is used in so many places that if you don't have this stuff down cold, you are going to suffer for it. This ability to work with linear equations and draw straight lines is important, not just for its own sake, not just for the sake of actually drawing straight lines, but also these concepts form the basics of how we draw triangles on the screen. And that means it basically forms the basis of all 3D graphics, because all 3D graphics are made up of triangles. And the concepts of linear equations and linear relationships, they permeate throughout all of games, programming, general programming, engineering. I'm going to talk more about that at the end of the video, but it's everywhere and you need to know it. And the math for these things is not super hard. It's just basic algebra when you break it down. And it's super important, so it's worth spending time and learning this stuff backwards and forwards. Now, the task that we're going to give ourselves today is very simple. We just want to be able to take 2 points and we want to draw a line segment between those 2 points. That's the code that we want to realize today. But before we get on to the code, let's talk a little bit about the general concept of a line and how we represent those things in terms of, mathematics. So when I say line, when people hear the word line, you think of something like this, right? It has a start, it has an end. But when math people, when they see something like this, they don't say line, they say line segment. A line is something like this that has infinite extent. It goes on into infinity in both directions. It doesn't have a start and an end. That's a general line. And a line segment is when you just say, I only want this section of a general line. Now, a line is described mathematically by a relationship, an equation that relates y and x. Once we get that relationship, we can then graph a line. And the most common form of that, we would see it written as y is equal to mx plus b. So we got y and x. We've also got these two constants in here, these two parameters. M, we call that the slope. B, we call that the y-intercept. And I'll talk a little bit more about those guys very soon. This is not the only way that you can represent a straight line or linear equation. It has many forms. All the forms can be transformed into each other with, basic algebra. And, some cultures for slope and y-intercept, they might use different letters. I think England maybe uses C instead of B. I don't know. Doesn't matter. I'm Canadian. I'm using this one. Deal with it. So this equation here, it defines a relationship between y and x, and we can use that relationship to generate a set of ordered pairs. Now, what the hell does that mean? Well, let's select an actual equation here. So we got y is equal to 2x plus 1. 2 is the slope, 1 is the y-intercept. Well, we'll worry about that later. But what we can do here is we can select a bunch of values of x. We can choose any values we want, and then we can plug those values into this equation, and then we can compute what y is equal to for that x. So we can start with, let's say, x of 0. So what does that come out to? That comes out to 2 times 0 plus 1 is equal to 1. So when x is 0, y is 1. And we can keep doing that for a bunch of other values. What if x is 1? That's 2 times 1 plus 1 equals 3. So here you can see I've done that for a bunch of different values of x. I've computed the corresponding y. And now we have a bunch of ordered pairs of x and y. And those are points on a graph. And if we actually put those points on here, so let's say 0, x is 0, y is 1, so that's right here. X is 1, y is 3, that's right here. I can keep doing that. And what you'll notice is that all these points, you can kind of see it even with these few points, but they all fall on a line. And no matter what x I choose here, so let's put in here -3. 2 times -3 is -6 plus 1 is -5. And if I plot that on here, -3, -5, you will see it also falls on the line. I can take my, we can take some black here, and I can carefully draw a line, and you see it passes through all those points. Any x we choose is going to fall anywhere on this line. And this is essentially how a computer can draw a straight line. You just have a loop. You loop through all the x's, the range of x on the screen. And for every x, then you calculate the y and you plot the pixel with put pixel. You just loop through x, calculate the y's, and then plot those pixels, and you have got a straight line. Humans, usually we don't have to do that. I mean, all you really need to do is choose two x's, any two x's, say this one and this one. Once you have 2 points, you know it's a straight line. You can then just put your ruler down on there and draw the line. If you're good with math, you don't even need to do this plotting of points, because you can directly look at the slope and the intercept, and you can say, okay, I know how to draw this line. So let's take a quick look at the meanings of m and b, the slope and the y-intercept. So from the name, you can probably tell that the slope controls basically the angle or the inclination of the line. So a higher slope is going to be a more vertical line, and a lower slope is going to be a more horizontal line. If you put the slope negative, it is going to slope in the opposite direction. And this makes sense if you just sort of analyze it a little bit mathematically. So here, let's put b equal to 0. So here we've got a base, the simplest line you can have, y is equal to x. And we can see here, if we increase x by 1, y is also going to increase by 1. Now, if we increase that slope to 2, we can now see that for every 1 increase in x, we're going to get 2 up in y. 1 over an x, 1 over an x, 2 up in y. 1 over an x, 2 up in y. And that's the meaning of slope. Another word that they teach you in school is slope is the rise over the run. So for every unit of run, how much do you rise? Well, here for every unit of run, you rise by 2. If you go in the other direction, for every unit of run, you rise by -2. Rise over run. That's your slope. Now b, let's go back into the base form, y is equal to x. So b is going to add a little value on the end of that, a little bit of an offset. I like to call this one the y offset. So if I put a y offset of 1, it's just going to shift this line up by 1, because for every point on the line, after we calculate the x times the slope, we add the y-intercept value, we add the offset. So it bumps the line up and down. So by controlling b, you control the offset of the line, and by controlling m, you control the slope of the line. And using these two values, you can get pretty much any line you want. One exception is a straight vertical line. That would require an m of infinity. We'll talk about that, how you get that a little later. Horizontal line, by the way, is m is equal to 0. So you multiply x by 0, and x just disappears. And that makes sense, because for this horizontal line, no matter what x you plug in to the equation, y is always going to be equal to, 0.9 or whatever. So x doesn't actually, for a horizontal line, x doesn't figure into the equation, so it doesn't actually appear in here. It just says no matter what x, y is always equal to 0.9, and that gives you a perfectly horizontal line. So like I said before, if you understand straight lines, you don't even need to plot 2 points and pull out your ruler to draw a straight line. You can just sort of say, okay, well, y is equal to 2x plus 1. The y-intercept is 1, so line is going to go through this point, and the slope is 2, so it's going to be about this slanty, and so the line is going to look something like this. I kind of fucked it at the end, but you get the idea, right? So you can examine the slope and the intercept, and you can understand what the line looks like, or you can manually plot 2 points and put a ruler and draw that line. But a machine doesn't really work that way. You basically have to loop through all of the x's and compute the y for each one and plot it, and that is what we're going to be doing. So let's write a simple little routine, a little loop to plot y is equal to 0.4x plus 200. Now, one thing that you have to keep in mind here is in mathematics, generally, you're going to have your axis set up like this. Your origin is at the center, and y positive is going up, x positive is going to the right. But in computer graphics, the way we have our system set up right now, the origin is at the top left, y positive goes down, yx goes to the right. So you're going to get a little bit of a different result plotting in this coordinate system than in this one. But in the end, it's the same concept. So here is our equation. What we're going to do is we're going to go for int x is equal to 0 as long as x is less than graphics screen width x plus plus. So we're going to loop through all possible x's on our screen, and for each one of those we're going to calculate const float y is equal to 0.4 f times float. We're going to convert that to a float x plus 200 0.4 f. That gives us our y. Notice we're going to do floating point because, we got fractions in here and stuff. And then we are just going to graph that motherfucker. So graph.putPixel, and we're going to do x, we're going to do int y, and we're going to do colors white. And there you go. This should give us a nice straight line. And there we go. We've got our straight line. Looks like it checks out. Y-intercept is at 200, and this looks to be about 200. And the slope is 0.4, so it's a horizontally biased slope, and it's sloping down, which makes sense. It's a positive slope, and our y points down, so the slope should also point down. So everything checks out. We can draw lines based on equations. The only problem with this is that we don't want to draw lines based on equation. We don't want to pass a function m and b. We want to pass a function 2 points and have it draw the line segment between those 2 points. So how do we go from talking in terms of slope and y-intercept to talking in terms of 2 points on the line? All right, so let's say someone gives you 2 points, -5, -3, and -2, 2. And we want to graph that line using a computer. Well, our algorithm needs the slope and the y-intercept of that. So the question is, can we calculate the slope and the y-intercept given 2 points? Well, let's look at it this way. If someone gives you 2 points, you can use a ruler and you can graph a straight line based on those 2 points. And once you have that straight line, you can inspect it. You can see the slope and you can see the y-intercept. So if you can get it that way using a ruler, then it should also be possible to get it using mathematics. So how do we do that? Well, it turns out all you need is some basic algebra. We know the equation y is equal to mx plus b. We have some data points. We can plug them into this equation and get 2 other equations based on it. We can get -5 is equal to, no wait, that's wrong. Rewind, -3 y is equal to m -5 x plus b, and we can also get 2 is equal to m times -2 plus b. So we can get 2 equations, both with 2 unknown variables, a system of equations. These are related because they both relate to the same straight line. And if you have 2 equations with 2 unknown variables, you can solve for those unknown variables. That's the hard way. The easy way is to understand the meaning of slope. So what is slope? Well, slope is just the rise over the run. That is equal to m. So what is the rise? Well, the rise is just the difference in the y positions of these 2 points. So we can do that is equal to y1 minus y0. And the run is equal to the difference in their x's. So x1 minus x0. And you could swap out the order. It doesn't matter the order. You'll get the same result. But we'll do 1 minus 0. So if we calculate that out, what is y1? That's 2. 2 minus negative 3 divided by, what is this? x1. x1 is negative 2 minus negative 5. So what is this? Well, 2 minus negative 3 is going to be 5, and negative 2 minus negative 5 is 2. Negative 2 plus 5, which is equal to 3. So the rise of a run, the slope, is 5/3, 5 over 3. So for every 3 we go across, we go 5 up, which is obvious just from these 2 points. We go 3 across, we go 5 up, and we'd be right here, etc. So we have our slope, but how do we calculate the b, the y-intercept? Well, now that we know our slope and we have 2 points, we can plug those all into the equation, get an equation with only one unknown. And then we don't have to worry about this system of equations bullshit. So how does that work? Well, let's choose a point. Doesn't matter which one. Let's choose P1. So y2 is equal to m, 5 over 3, times x, which is negative 2 plus b. So then all we got to do is a little bit of math. We subtract this quantity from both sides. This cancels out. So we just got to subtract. The final thing is b is equal to 2 minus 5 over 3 times negative 2, which is equal to 2 minus, well, it's going to be 2. If we multiply 2 negatives together, that's a positive. So it's going to be 2 plus 10 over 3, which is equal to 16 over 3, which is equal to about 5. And I mean, if we graph this straight line here, let's see if I can get it. We'll see that, it pretty much does go 5 and a little bit. So it's fairly accurate. So directly using these 2 points, we can find the differences in their y and their x coordinates, and that gives us the slope. And then we can plug the slope in with the values of 1 point, get an equation with one unknown, solve for that with a little bit of algebra. And we can, rework that into a formula that we use in our code. And the formula is very simple. Once we've solved for x, or once we've solved for m, we have y and x. B is just equal to y minus mx is equal to b, right? We just subtract, just basic algebra. So here's how you calculate your m. Here's how you calculate your b. Let's get going. All right, let's get down to business. First thing I did, I'm going to add vec2 because it's going to be useful for us. So I just pulled that in from a different project. Now in graphics.h, we want to add a function to draw a line segment. So it's going to take 2 points and it's going to draw a line segment between those 2 points. We're also going to pass it a color, and that's going to look like this. We create the definition, and let's expand that. Now the first thing that we need to think of is that the user can give us P1, or P0 and P1, but they can give us in any order. So when we do our loop through x, we want to loop from the one with the lower x to the one with the greater x. But if we just loop from P0 to P1x, what if they gave us in the opposite order? What if P0 was here? That would be a problem because P1 would come before it. So we would try to loop from this one to P1, and it would just immediately stop because P1x is already less than. So we have to swap it so that P0 is on the left, is basically what I'm trying to say here. So what we want to do is we actually want to create temporaries of these two vectors. And if we're going to do that, we might as well just pass these guys in by value. if that's the game that we're going to be playing. So we'll just get rid of the const on these guys. Toggle header code, and we'll also get rid of it like that. That's great. All right, now you should be not angry anymore. And what we want to do is if p0.x is greater than p1.x. So if it is on the right of p1, then we want to do std swap p0 p1. That's not a p. There we go. And that should get them in the correct order. So that's business number one taken care of. Now we want to calculate the slope between these guys. So the slope is just equal to the rise over the run, which is going to be p1.y minus p0.y quantity divided by p1.x minus p0.x quantity. There you go, you've got your m. Your b is going to be y0 minus m times x0. And now we just got to run our loop. So for drawing a line segment here, we don't want to loop through all the x's on the screen. We only want to loop from the x of p0 to the x of p1. We don't want to draw the entire line. We only want to draw the segment between these 2 points. So we can do for int x is equal to p0.x, and we want to convert that to an integer. I like the loop in integer rather than in floating point in general. And as long as x is less than, we'll just do the conversion in here, p1.x, x plus plus. There's some things we can tweak later on with in terms of how we want to round things, but to start off with, we'll just keep it simple. So we loop through all the x's, and then we go const float y is equal to mx plus b, and then we do put pixel xyc, convert y to an integer. So in compose frame, we are gonna do graphics.drawLine. We're gonna give it 2 points. And let's go from 50/50 to 500/100. And if we run this, that does in fact look like the expected result, right? This is 800, looks about 500. This is 50. This looks about 100. Yeah, it looks good to me. So we've got our line segment drawing routine all done. That was simple, wasn't it? Yeah, as a little victory lap, let's just spice things up a little bit here. We're going to draw a line if left mouse button is pressed from 100 to the position of the mouse pointer. And if we run that, let's put the mouse somewhere good. And if I press the mouse button, yeah, there we go. We've got our holding the mouse button down, and we've got our line. Let's get a little slant here. And oh, what the hell is this? This well, it doesn't look the greatest. Let's see here. I don't know. I don't know about this one. I don't know about this one, guys. So what's going on here? I think you guys probably already can see what the problem is, but the way our thing works is we're looping through x, and for every x, we draw a pixel. And if your rise over your run, if your motion in the y direction is very large, then you're going to have gaps between your pixels. So if you have a very gradual slope, then you're going to be drawing, like this. And it's going to look fine. But if you got a very steep slope, then you're going to have gaps in between your pixels. And it's really bad if you want to draw a vertical line, because first of all, calculate the rise over the run, you're calculating the difference in the y minus the difference in the x. For a vertical line, x's are going to be the same. You're going to be dividing by 0, which, depending on how you do it, can cause a lot of problems. So you don't want to divide by 0, and you don't want gaps between your pixels. What are you going to do? Well, the answer is basically we can change our strategy depending on what kind of slope we have. So if we have a slope that is horizontally dominant, we loop in the x. But if it is vertically dominant, or if it is completely vertical, then we want to loop in the y. So we want to change our equation, change our loop, and then we will not have gaps between our stuff anymore. So instead of doing y is equal to mx plus b, we're going to do something like, I don't know how we would call this. X is equal to wy plus p. See what I did there? Because W is like you flip an M and you flip a B and it becomes a P. Yeah, you see what I did there? So we do X is equal to WY plus P. And W, this is probably hard to read. Let me give you a different color. W is going to be equal to now run over rise. So it's just the flip of M. And so how do we calculate P then? Well, P is going to be equal to X minus WY. So the first thing we do is we determine which case we're in. And then what we want to do is calculate our things, either M and B or W and P. And then we run our loop and we draw our line. All right, so the first thing you want to do is you want to figure out if our line is horizontal or vertical. Now to do that, we need to basically just calculate its slope. But I don't want to calculate the slope if it is a completely vertical line because I don't want to divide by 0. So what I'm going to do is I'm going to go float m. And here I am going to do if p1.x is not equal to p0.x. I could have done that the other way around. Doesn't matter. So if they are not the same, meaning if it's not a completely vertical line, then let's calculate that slope. And we'll do that like this. So we'll pre-calculate the slope. Now we're going to check to see which case we have. So first, we want to see if we have a completely vertical line. So if our line is not completely vertical, and if that's the case, then that means we would have calculated m. So and if m is less than or equal to 1, then we have ourselves a horizontal line. Horizontally biased line is a line of the horizontal persuasion. Let's just give this one a default value. Compiler will probably like that better. So we calculate our m here. If it's not completely vertical, this will tell us if we have a horizontal line. If so, we can proceed as normal. We don't need to calculate m here again because we already have it. So we just calculate B, we swap if necessary, calculate B, and then go along our merry way. Now, if we have a vertical line, we need to reevaluate our life decisions. So we want to calculate W, which is going to be basically the inverse of M. Well, first off, let's get our points into the correct order. So we want to order them not by X, but by Y. So we want P0.Y to be greater, or if it's greater, then we want to swap them. So we want P0.Y to be less than or equal to. Then we can calculate W, which is going to be the run over the rise. So we can go Control X. We can put a slash in there, and then we can delete this guy. Okay, so now that we've got our W, it's going to be simple. We also got to calculate our P. Slightly confusing because P also means point, but you get the idea. And that is going to be X minus W times P0.Y, I believe. And then our loop is going to be the same idea, but using Y. And that is going to look something like this. Let's get rid of that extra line there. And I believe that this probably will do it for us. Although probably not. There's always going to be like a bug or a compiler error somewhere, some kind of copy and paste bullshit that I forgot. But let's give her a try. So the moment of truth, let's click the left mouse button, and we're getting good lines here. We're getting good lines here. And okay, well, I guess, yeah, so we're not doing so hot on the negative slopes. That's probably a problem with our comparison, I believe. So how do we solve that? Well, we're doing m less than or equal to 1, but that means that negative 50 will work. We don't want negative 50 is also a steep slope. It's just a steep slope in the opposite direction. So what we want to do is we want to compare the absolute value of the slope, and we want to see if that is less than 1. That will give us better results. So yeah, there's always one thing that you do that messes it up. Now, there are a couple of enhancements or fixes that you could do for this to make it a little better. First off, it runs from P0, but it runs up to but not including P1, and you might want it to include P1 depending on what you're doing. So here you see we're not getting that final pixel in the bottom right, for example. So that might be something that you want to change just by adjusting the loop. The way we're doing our calculations is we're just truncating, right? We're converting stuff from float to int here and here, and you might want to round to the nearest, so you could do that by, there's functions for that. You can also just add 0.5, and that'll do it for you quick, but I really don't care that much. If you want to get super into it, there are actually very detailed and specific rasterization rules that different graphics APIs use, like Direct3D or OpenGL, and these will give you incredibly consistent results if you follow them, but they're also pretty complicated to implement, as you can see here. But I mean, if you're a crazy person, you can try this as well. I, however, am happy with this result. This is more than what I'm going to need for future tutorials, and it's enough for me to demonstrate the ideas of linear equations and graphing lines. Now, you should also note that the algorithm that I've shown here, its main advantage is its simplicity. It directly maps to the idea of creating a table of values of plotting points, but it's not the fastest algorithm, to be sure. There are much faster ones. For example, Bresenham's line algorithm is basically the go-to for drawing lines, and it uses a kind of a delta approach. So you can try to implement this if you're really interested in, min-maxing your line drawing, but trust me, in the stuff we're doing, line drawing speed is not going to be the limiting factor. So I don't care. I use this one because it's very easy to conceptualize in terms of the linear equation. But there you go. There is how you would plot a line graphically in C++ given 2 points. And more importantly, I've shown you the basics of linear equations and how to manipulate them, and what the different parameters mean. And that is actually the real lesson of today. Because like I said before, linear algebra and these kinds of equations aren't just used for drawing lines, they're used all over the place. So for example, if you've got some kind of piecewise data set, like back in the day when you wanted to calculate sine or cos, you would be given a table of values like this. So for example, the sine of 0 degrees is 0, the sine of 40 degrees is 0.6428. But what if you wanted to calculate the sine of, let's say, 39.1 degrees? How do you get that? That's not in your table. I guess you're screwed. Or not, because if you have a data set of a bunch of discrete points and you want to find a value between those, what you can do is you can linear interpolate between the two data points you have and find something in between there that's probably pretty close to the actual value. So instead of the dumbest way would be just which is closest. So let's say I wanted 2.4, but I only had data for 2 and 3. I could just take the data for 2 and say, well, that's the closest. But a better way is to blend 2 and 3 together proportionally. So 2.4 would be somewhere around here. You draw a straight line between the two data points, and then you find your intermediate point on that straight line. That's linear interpolation. It is used all over the place. You've already seen me use that technique when I did alpha blending back in intermediate. To blend between two different colors using some alpha value between 0 and 1, that is a form of linear interpolation. But also, when you're drawing triangles, you are interpolating different parameters like texture coordinates and colors and normals and all sorts of things. Interpolation is essential for the idea of rasterizing triangles, which are essential for 3D graphics. So there is an ass ton of applications. I've only just listed a few off the top of my head here, but there are tons of applications for this stuff, and it's not that difficult in terms of the scope of mathematical knowledge and the difficulty of different fields of mathematical study. This stuff is really simple, so it's worth your time if you're not already really comfortable with these equations and these manipulations. It's worth your while to spend some real quality time just developing your skills with these linear equations and your fundamental linear algebra. Alright, now for the homework, I've created a suite of math problems here, and you're going to solve them. And these are all just pretty much basically linear algebra problems. There's a couple in here that aren't linear. At least there's one in here that isn't a linear equation, this one. But the rest of them are all pretty much linear equations, just manipulating algebra and stuff like that. And I want you to solve them for the practice, for those of you who might be a little rusty, but more importantly, this should serve as a diagnostic. So if you can solve these fairly simply without having to resort to looking things up, then you should be good to go. But if some of them stump you pretty hard, and especially if you have to stop and look things up because you can't figure out how to solve a problem, then even after you finish these, I recommend that if you're serious about learning this stuff, the graphics and the 3D stuff, then you should probably take some time, take several hours, and study this topic separately. A good place to start would be probably Khan Academy, but if you guys have any suggestions for learning these sorts of mathematic topics, if you got links, leave them in the comments and upvote the ones you think are good, and I will add them to the wiki. But anyways, solve these problems, and I will come back at you with the solutions on video. But that's gonna about do it for today. Thanks for watching. Hope you enjoyed the video. If you did, please click the like button, it helps a lot. And I will see you soon with some more advanced C++.